Yo, yes, we are back. Thank you all for joining me again on this awesome journey of thermodynamics. We have done one session already on thermochemistry, and the reason मैंने अलग-अलग sessions किए was because यार JEE asks a lot of questions on thermochemistry. So I thought, boss, it deserves its own session. Khair, hold on. You should be able to see me right about now. What's happening? Yeah? आवाज साफ आ रही है? You able to see me and all that? Yeah? What's up? What's up? What's up? Ooh, very green background, huh? Literally. Hara hara. Sweet. Let's get started. Yeah. Good evening. Pranam, pranam, pranam. Yeah. Fashionably late. No, man, my streaming software just decided to crash on me. So I was restarting that. Luckily, computer restart nahi karna pada. But yeah. Khair. I'll just quickly go over some theory that I think is very relevant for this, and then we'll go ahead and, as usual, right? Oh, wait. I was wondering how itna niche kyun hai. All right. That's better. Hey, shadows descended. Let's talk about thermodynamics right now. If you want to ping me, want to chat, maybe go on to I Teach Chem on Discord or Telegram and we'll chat. All right. Let's now focus on thermodynamics. Cool. So I did the last session. I started with this same diagram because it's been a week. Let me quickly recap. Okay. I've got one setup over here. I'm trying to increase the temperature of a gas. I've put some pistons on top, which means it's constant pressure, right? अगर मैंने ऊपर weight डाल दिया मतलब pressure हो गया constant. Volume ऊपर नीचे हो सकता है. Piston is freely movable. So I'm heating it from the bottom, right? And the gas expands, pushing the piston on top. Well, pushing that piston. ये वाला तो fixed है. So there are two different things. That one over there at the bottom, I'm calling that QP, दूर वाला. और जो पास वाला है, I'm calling it QV. And I said that QV is less than QP, या फिर QP is greater than QV, क्योंकि some of the heat goes in expanding the gas. Okay, in this case, all the heat, in case number 2, all the heat goes in increasing the temperature. दोस्तों, हीट और टेम्परेचर दो बहुत ही अलग अलग चीजें हैं एंड थर्मोडायनेमिक्स स्टडीज द फ्लो ऑफ हीट. टाडा. कुछ समझ में आया? हाँ, बता दो अगर समझ में नहीं आया तो. राइट. हीट इज जस्ट लाइक करंट. इट फ्लोज व्हेन देयर इज अ डिफरेंस इन पोटेंशियल. इलेक्ट्रिक पोटेंशियल करंट एंड टेम्परेचर डिफरेंस हीट. दैट्स इट. या झरना बह रहा है एटसेट्रा, दे टीच यू राइट हाई पोटेंशियल टू लो पोटेंशियल, सेम आइडिया, हाई टेम्परेचर लो टेम्परेचर. खैर, इसीलिए यहां पे मैं हीट ऐड कर रहा हूं बिकॉज ये तो बहुत गर्म है. दिस 900 डिग्री और समथिंग व्हाटएवर. मैं इसके अंदर गैस है पूरे सेटअप के अंदर. बोलना भूल गया था लास्ट टाइम, बोला था फिर से बोल रहा हूं. व्हेन यू हीट दिस, द फर्स्ट वन में ज्यादा एफर्ट लगता है, ज्यादा एनर्जी आती है बिकॉज सम ऑफ दैट एनर्जी गोज इन एक्सपैंडिंग द गैस एंड द रेस्ट ऑफ इट इंक्रीज द टेम्परेचर. इन द सेकंड केस, ऑल द हीट एनर्जी गोज इनटू जस्ट रेजिंग द टेम्परेचर. ठीक है. इसीलिए द हीट इन द फर्स्ट केस, ओके, इज ग्रेटर देन द हीट इन द सेकंड केस. I am putting this thing called QP versus QP, मतलब constant pressure versus constant volume. All good? Yeah? Understood? Great, great, great. Awesome. ठीक है. ये तो recap from last time, right? And then I said कि okay, चलो इसको expand करते हैं, तो कुछ work is being done against that pressure. What is work? Force into displacement. Dot लिखा क्योंकि dot product होता है. And then you say अच्छा, this is the D, ये distance है, area है, तो area into distance will give me volume. Force is M times G. Area is, force by area is pressure, which is mg by a, and then you get mg by a into total volume of the gas, which is D times a, gives you P delta V. ये है quick derivation of irreversible work happening over here. P external times delta V. Okay, and in chemistry we define work as negative P external delta V because देखो chemistry में displacement है इस direction में, force है इस direction में. That's all. But that's not important here because work is a scalar quantity. Positive or negative work is just like bank balance. अगर पैसा आया अंदर मतलब work done on the system, that's positive. पैसा बाहर गया, work done by the system, that's negative. मतलब कि compression work is positive, expansion work is negative. If you want to mug something, mug this. Okay, don't mug random things like बहुत चीजें लोग mug करते हैं. I will not talk about that. Let's focus on what to mug. You gotta mug this. Okay, compression work is positive, expansion work is negative in chemistry. All right. Cool, 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 cool. Delta E is the total energy which remains constant. That is the first law of thermodynamics. For us, we will talk about potential energy and kinetic energy. Potential energy कहां से आई? Heat. या फिर bonds में. When bonds form and bonds break, then there is a change in energy which is potential energy. ठीक है. और जब things move around very quickly, that is kinetic energy. So gas expands, no reaction happens, that's kinetic energy. When a reaction happens, it's usually potential energy. और हम लोग इसके बारे में बहुत बात कर चुके हैं in the previous session. Okay. थर्मोकेमिस्ट्री में बहुत बात कर चुके हैं इसके बारे में. चेक दैट सेशन आउट. आई लिंक देम बोथ टुगेदर ताकि आपको ढूंढने में आसानी हो, बट दैट इज व्हाट वी हैव डन इन डिटेल. व्हाट्स अप? Wow, Megha. Hey, Ayush. Wow, काफी late for you. You wish you understood this chapter. You will understand this. Don't worry. ये this part you will understand. ठीक है. Potential energy change. अरे ये तो उल्टा हो गया ना. Kinetic energy. हाँ. Kinetic energy is work. Potential energy. ये हमने फिक्स किया था उस वाले में. इस वाले में फिक्स करना भूल गए. ठीक है. Anyway, अगर potential energy नहीं है, अगर कुछ नहीं हो रहा है, सिर्फ वर्क हो रहा है, like QV, QV में क्या होता है? अच्छा, यहाँ पे जो पोटेंशियल जीरो नहीं होती है, सिर्फ किनेटिक एनर्जी के कारण होता है. सो डेल्टा ई इज डायरेक्टली गोइंग टू बी इक्वल टू किनेटिक एनर्जी, राइट? मतलब कि कोई रिएक्शन नहीं हो रहा है, कुछ नहीं हो रहा है, सिर्फ मूवमेंट हो रहा है, एटसेट्रा. ओके, सो QV में टेम्परेचर इज व्हाट the internal energy depends on. So we get the whole thing to be QV equal to NCV delta T. I know I'm going a little quick, but if you have any doubts, tell me. This is supposed to be a PYQ session, but I'm revising some theory that I think is important for us to understand this. Okay. Let me know. Let me know if you like this. Yeah. All right. Sweet. All right. So this is the first law in the what do you call it in the mathematical form, right? Delta U is Q plus W. Uske niche I've written two more equations. These two we did in thermochemistry in detail. Okay, if we've done this, please check them out. And this is another form of this same first equation. How do you say is the same as this? Dekho, delta U is equal to QP plus W. Delta U is equal to delta H plus minus P external times delta V. Take it to the other side, you get the same expression. अरे ये तो हमारे पीछे चला गया, हम चले जाते हैं इस तरफ ताकि आपको ये दिख जाए. ठीक है, cool. I'll give these notes. You don't have to write anything down. Just listen. प्यार से आप सुनिए. Okay. At constant pressure, you can say that this is equal to this, and this is NCP delta T. This is again revision of things. Please, यार thermo पढ़ के आओ. This session is for people who have studied thermo. If you haven't done thermo, check out my sessions on the NEET channel. I've done thermo in detail over there. Okay. Anyway, shall we move on? Yeah. Work is defined as negative P external times delta V. Okay. And this may be hard for students to remember because sometimes they think plus है minus है याद नहीं रहता है. ठीक है, we'll figure that out as well. I told you how to remember that. Expansion work is negative, compression work is positive. Here's a quick question just to make sure everyone is awake. Sign of work done when gas expands, gas contracts. What is it? Positive, positive, negative, 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 positive, or positive, positive? Batao, batao, batao. Swarit, I am in Byju's. You look at the logo on top of my head right there. It says AB. That's Aakash Byju's. This is the Byju's. Right? All right. Let's go, let's go, let's go. Ha, Samyak. Here's one question. Yeah, what do you think? Very easy one to start off with. Yeah, very easy one to start off with. C. Yeah, Samyak and Rek both saying C. Like this. Very nice, very nice. Rek, Sai, Kiran. ठीक है. This one you know. What is it? बता दो Ayush. Sai. Yes, Ayush. Absolutely. Simple stuff. All right. Sweet. Now, this is what is new from here. ये चीजें मैंने last time नहीं की थी. I didn't ask you that question also now. So the focus of this session, by the way, 10 minutes in, you know how it happens, right? Movie शुरू होती है, पहले fight scene और action होता है, then they tell you बीच में आता है नाम movie का. That's what's happening right now, right? We are going to talk about the first law of thermodynamics over here in this chapter, in this session. Next session में we'll talk about entropy, delta G, and Gibbs free energy, and also equilibrium. These relations we'll do the next part of this. अगले हफ्ते करेंगे sometime. ठीक है? Today we're going to focus on the first law. क्योंकि यार JEE में disproportionately ask questions on the first law and thermochemistry और थोड़े साल उसमें पूछता है. So that's why it's a three-parter. खैर, now I've drawn these yellow kind of a thing. This is the boundary of this sort of a process. What kind of a process? मैं गरम कर रहा हूं. Okay, and there's a fixed path to this process. What's the fixed path? I have said that boss, pressure is constant. Okay, this is the fixed path. Now, in this fixed path, ये path कैसा हुआ? This path is different from the path that you take around the park. Okay, you're going from point A to point B. Here, the states are defined. Okay, here the path also is defined. It may be by a line, but sometimes a line is seen, sometimes a line is not seen. We'll talk about that in graphs very soon. खैर, ये boundary है इस process की, and this boundary definition is that it should be defined. You will notice that in this case, देखो boundary बदल रही है. See? When I expand the gas, the boundary changes, and that's absolutely fine. The boundary can expand, the boundary can contract. The boundary needs to be defined. Boundary की हम लोग क्यों बात कर रहे हैं? Yeah, कि अगर boundary है, then you based on the boundary you define different types of system. Okay, a system is this gas right now. Anything inside the boundary is a system. In this case, it's the gas. Surrounding is everything else. System surrounding का definition. इस पे भी सवाल आते हैं. आपको लग रहा है कि यार आशीष तुम ये क्यों सब कर रहे हो? ये सब मुझे मालूम है. System surrounding boundary मालूम है तो बहुत अच्छी बात है. आसानी से आपको मिल जाएंगे 4 मार्क्स. Questions have come on system and surrounding as well. Anyway, so If there is neither mass nor energy that is passed around through the boundary, then it is said to be an isolated system. If mass is not allowed, energy is allowed, it's called a closed system. ठीक है? रुको, इसको मिटाना पड़ेगा. That will come up on your screen as well very quickly. Here you go. So, अगर heat, if it lets heat या फिर Q pass, A हो गया तो Q pass, then it is a closed system. If it lets both heat and energy pass, it's an open system. We good? We good? Magha ji, I am talking in English. Yeah. Kritik, I am talking English, guys. When I'm talking English, you ask me to talk in English. Or how much more English can we get, right? I'm great, Harshvardhan. Yeah. So, to summarize everything so far, yeah, boundary is something that if it lets heat pass, it's called closed. It does not let mass pass. No mass. Okay. All right. The system here was gas, surrounding is everything else. Work done on the system is positive. Q in the system is positive. What I want you to remember is compression work is positive. Otherwise, these two definitions get confusing. Work done on the system, Q in the system, these were positive. Any doubts here? And remember, both work and Q, they are scalar quantities. They are not vector. They are not directional. They have a positive and negative sign, just like a bank balance has a positive and negative sign. I hope bank balance negative sign now, but bank mein when money comes in, that's positive. Money goes out, that's negative. That's what we're talking about. So heat comes in, or work comes done on the system, that's positive. Work is done by the system, or the heat goes out of the system, that's negative. All right, sweet. Boundaries, there are three types of boundaries. Based on the boundaries, there are three types of system: open, closed, and isolated. No mass, no energy. Okay, here no mass, yes energy. Okay, here energy, mass, dono open. E is energy and M is mass. All right, sweet. ठीक है? Chalo, let's look at a little bit of more theory and then we'll start the questions right away. A little bit more question, a little bit of theory. Huh, that's very interesting, Magashri. That goes over my head. What do I remember? Harshvardhan, Pranam, yeah. English premium, yeah. We are all doing premium stuff right here. This is the best content you'll find on YouTube on this for the Indian syllabus. Okay, so here I've got two different processes. Okay, the same pressure, same volume, and the shaded part is the work done. Do you follow this? I'm slowing down here because this part is ridiculously important. This shaded part is the work done. This shaded part is the work done. Okay, is that okay? Is that all right, guys? Which college? Many colleges, Sai Kiran, ISC, NIT Surathkal, and RV. That's a story for another time. Yeah. Can you guys please figure this out? Yeah. That this work done is given by this graph. Yeah. How? In compression, the definition is the same. P external times delta V. In compression, yeah, PF is P external. In expansion, here, this is P external. Well, in both cases, external pressure is the final pressure and that changes the work done drastically. Do you understand this? Yeah, if you're from class 8, I'm sorry, but this lecture may not be for you. This one specifically. I'll do theory sessions, you can attend those. This one is going to be too heavy for you for class 8. I'm just going to be very straight with you. Okay, Mega? It's lovely that you're here, but yeah, it's going to be a bit uphill for you. Do you follow this, guys? How is it that between the two same states, work done is different when I do expansion and when I do compression? Do you understand that? Do you guys understand that? This is extremely important. That's a one-step process. What is a one-step process? I go from here, from this state to, from this state to this state. Similarly, I'm going from this state to this state. Okay. So state 1 to state 2. And these are irreversible processes. How do I know? Because irreversible cannot be plotted on a graph. They're like, hold on, I have plotted on a graph. I have not actually, because I have just said that bhai, final pressure is external pressure and we just work happens to be by that. But this is not really plotted on a graph. I'll tell you what I mean. Now I'll make this a two-step process. Now see what's happening in a two-step process. In a two-step process, look at this. I am going from 1 to 2 to 3. Similarly, expansion, I'm going from 1 to 2 to 3. In all of these cases, see here, this is the intermediate final stage, intermediate this thing. So you see that compression work reduced. You see this? This is in first case. Yeah. Second case, look at that. Compression work is reducing. Do you see that? Hey guys, time pass mat karo. Let's focus on this. Yeah, compression work is reducing and expansion work is increasing. Do you see that? The area under the graph is increasing. Area under graph. In case 2 is going up, in case 1 is going down. Do you see that? Let's focus on what I'm saying. Pressure is invariable in irreversible. Samya, okay, absolutely, absolutely. Hey, Sai, Shiva Vignesh, great to see you. You're from Madurai. That's beautiful, beautiful. Madurai is really good food. I really like Madurai sambar. It's amazing. It's my favorite kind of sambar. Yeah. All right. So, do you see that? And the moment I increase the number of steps, yeah, this keeps happening to an extent where something very fascinating happens. See, again, in 1, this is decreasing, okay? The work is decreasing, and in 2, the work is increasing. So you reach a state where you get to this beautiful reversible state, okay? Where you have infinite number of steps. This is exactly the same as integration. If you guys like math, like me, I love math. I absolutely love the graph part of math. What did we do? We integrated, right? You keep increasing the number of steps. If you keep increasing the number of steps, you get to infinitesimal small steps, and that is integration. And that's why you have integration, reversible expansion, reversible compression. But see this, look at this. This is the minimum work done, and this is the maximum work done. Okay, so that's what I want you to see. The compression work is minimum when you have reversible processes. Expansion work is maximum when you do reversible process. For example, 1 step, okay, to give you comparison, and this is 1 step for both of them. If I go to infinite steps, देखो कितना कम हो गया. It has reduced by this much. Let me use a different color. Yeah, reduced, and this is increased by this much. Increased by this, okay, and this has reduced by this. Do you follow this theory? Yes? Guys, I love what Sai Kiran is saying. Infinite steps, reversible process. Absolutely right. Shiva, come on, Shiva. Let's focus on thermo, yeah? It's great to see fellow people from your same place, but let's focus on this. Okay, beautiful. Now, this is what I want you to appreciate in thermodynamics and in first law especially. That's all. So, in summarizing everything, work reversible is, greater than work irreversible when you're talking about expansion, when you're talking about compression, ulta hota hai. That's all. So, to summarize all of this, work is always done against some sort of external pressure. Okay. Now, if you do 1 step, 4 steps, etc., 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 compression and expansion ka hum log figure out kar sakte. Okay. Now, what do we do now? Let's finally look at MCQs, right? You wanted this. This is the format you wanted, right? You wanted me to do some theory and then some PYQs. So here, yeah, we've done enough theory to last you a lifetime. Now, quick question. What is the sign of work done when gas expands and when gas contracts? Tell me. Again, please let me know in the comments. Plus, minus, minus, plus, minus, minus, plus, plus. Give me that. Folks, respond, please. Mother tongue. I've always found that concept weird in India, right? In India, we speak more than one language. Everybody speaks so many languages, right? Anyway, I speak Hindi and English primarily. Yeah, I understand Kannada mostly. I understand Tamil somewhat. I understand Telugu also somewhat. I've been in Bangalore, so I understand most languages. I speak Hindi and English though. All right. So negative is what all of you are saying. Sai, Sia, Rek, Hazuo, wow, and Kirtik, who is, I think, unka naam something else hai. Positive is what Kirtik is saying. But I would like to go with these 2 ideas, what everybody else is talking about. That, yeah, negative in case of expansion, positive in case of contraction. Absolutely right. That's exactly what I want you to remember. Expansion work is negative, compression work is positive. Sweet. Okay. Now, a quick summary of everything on all of this, right? And this is something that sometimes students forget. These are all different kinds of paths. Look at this. Irreversible is a path. Reversible is a path. Isothermal, adiabatic, isochoric, and isobaric, they are all different paths because you're fixing something. Okay, so it becomes a way of doing it. It so happens that some of these paths lead to state functions. Like reversible, a lot of times, some reversible things lead to state functions. We'll talk about that another time. Yeah, but quickly first, irreversible work done is given by this. Reversible dW is equal to minus PdV. Integrate to get work done. Okay? Isothermal में delta T is equal to 0. So if you say delta T is equal to 0, then Q is minus W, delta E 0 and delta H is 0. This is very, very important. And using this, you can solve any JEE advanced question also. I'll show you as proof. Very soon I'll show you that. Okay. And you integrate this, you get this to be the result. A lot of you say, na, bhai, mujhe formula de do, give me formula. Here, all of these are formulae. You don't write anything down. You don't write anything down. You have to just take these as notes. Okay. Adiabatic is Q0. What is Q0? Delta E is equal to W and PV power is gamma is equal to constant. I'll do the derivation for you. We'll do that quickly as well. Do you follow this? Any doubt? All good? Yeah, that's all right, Kritik. All good? We're all right? Neat, huh? Neat is beautiful. Neat is amazing. Isochoric delta V 0, which means work done is 0. Okay. And you have to identify these in graphs. The only thing that's different in advanced from JEE main is in advanced they ask you graph questions. And in JEE main they ask you direct number wala questions. Yeah. Otherwise, I think JEE main and advanced questions are almost at the same level in thermodynamics, in my opinion. But my opinion is a little tainted, no? Because bhai, I've been doing this for some time and I like the subject, etc., etc. So yeah, it's possible that maybe you're like, no, that's not true. But my main difference that I've spotted is that in JEE advanced they ask you graphs, in JEE main they ask you direct questions. Anyway, P external delta V is going to be equal to 0. Isobaric, nothing changes. All right, let's start with simple questions. The total number of intensive, this is from JEE main 2023. The total number of intensive properties from the following is, you've got volume, molar heat capacity, molarity, E naught cell, gives you energy, and molar mass and mole. 1, 2, 3, 4, 5, 6 and 7. Out of these, this is a numerical entry question, guys. Another thing that's different in JEE main and JEE advanced. In JEE main, your numerical entries have negative mark, and in JEE advanced they don't. Did you know that? Anyway, answer 30 seconds. It's a number. It's a number, Sai Kiran. You need 30 seconds to solve this. You see it, you know the answer. Mark it. Move on in life. That's what questions like this are about. Easy, easy, easy marks. Can you try this? Can you give me the number on the chat, please? Try it out, folks. Zyada intense ho gaya? Come on, this is how it is. It's fun. Yeah? Go ahead, go ahead, go ahead. 2, 3, 4, 6. Okay, Sai. So Sai is saying 4. Sai is saying 4. Rek is saying 3. All right. I have quickly marked the ones that I feel are correct. What do you think? Okay. Sai is saying 2, 3, 4, 6. Beautiful. Well done, Sai. Lovely. Excellent work, Sai. Do you guys follow why Sai said 4? And which 4? Rek is saying 3, Sia is saying 2, El Dorado is saying 4. Yeah? Yeah? So let me write down Sia saying 2, and El Dorado is saying 4. Would you like me to explain how it's these 4 that are intensive? Let's do the ones that are extensive. That is easy to understand. What is extensive? Extensive matlab ki if I go and point at one point, it doesn't have any value. Intensive matlab at any point, the property I'm talking about, it will have a value. Yeah, that's the easy way to remember intensive and extensive. Another way to remember extensive and intensive is extensive depends on the mass of substance, right? That's one way. The other way, the actual definition is intensive matlab at a particular point it has a value. Extensive matlab it doesn't. So volume at a particular point has no meaning. So we can cross this out for sure. Okay. Molar heat capacity, yes, here or here or here of one particular gas is always going to be the same. So this does work from that point of view. Molarity also, right, of a solution. Molarity, whether I take this part of solution, this part, it's going to be the same, right? E naught cell, same idea. Gives you energy? No way, right? Gives you energy it doesn't make any sense. If I have this glass of water, right? I can talk about the gives you energy change of the whole thing. If I pour it down, I'm not going to pour it down, don't worry. Yeah, but because I have some entropy, right? It'll spoil and all that. I'm not doing any of that. But I'm just saying, but if I I'm not going to put my finger in there either. But if I do that, it doesn't make sense to talk about it gives you energy. So this one's off the charts. Molar mass, for sure. Similarly, mole no. Okay. Anyway, Sita, if you have a doubt regarding what I'm talking about right now, sure. If not, if it's about general chemistry, then ping me on I Teach Chem. I am going to take a sip of water, which is in my hand. Ping me there. We are good. Do you understand this? Any doubt in this question? Please ask me if you have a doubt on this question. Kritik, I just did, right? The easy way to do it, right? The easy way to do it is to figure out if the property depends on the mass of stuff, like volume. If I increase the mass of something, its volume also will increase, right? Because its density is fixed. If I increase, if I have this much of water, whether it's like half a glass or full glass of water, the moles would change. So it's definitely extensive. Same with gives you energy, right? If I take 1 mole or 10 moles, it will change. That's the easy way to do it. What I told you was a more scientific definition, intensive, extensive wala. The easy way to do this with the idea of mass. All right? Wow. I have no idea what Sita is saying, but that is so random. I don't even know what to do with that. Yeah, you guys are having fun on YouTube, aren't you? But it's okay. As long as it's not disrespectful, I'll allow it, whatever time pass works. Sai Kiran, molarity contains moles of solute but does not depend on mass of solution. Yeah, because it's a ratio. Molarity, it's a nice one. Let's talk about molarity for half a minute or so. Molarity is mole divided by volume. Now, both of these are extensive, but their ratio is intensive. Yeah, the ratio is intensive. That's interesting. And that's actually the case. The ratio of two extensive properties gives you an intensive property. I like that molarity wala spot. Good stuff. All right, we all right? Sita, yaar, time pass mat karo. Come on, let's focus on what's happening here. Kirtik, are you good with this? I know this is seems like a very direct question, but since you're here live with me, you have the luxury of asking me doubts, and I'm here to solve them for you. Don't worry. Jitna time lagega, lagega. We'll sort this out. Yes, absolutely right, Eldorado. Beautiful observation. Beautiful observation. Yeah. All right. Think about it. Take as many examples as you like. It'll always work out. Yeah. Yeah. Great, Sita Devi. Please go off the line. Do whatever you like. The work done when 3 moles of an ideal gas expands reversibly and isothermally from a volume of 1 liter to 10 liter at 300 Kelvin is what? How about this? This was a question asked in a previous JEE paper. It was asked in MCQ, as an MCQ. I changed it to a numerical entry because I feel you can do this without having options, right? You have options in life. You always do. Yes, Sita, you have an option in life. Being mature. That's an option in life, Sita. So here you go. R is 0.0083 kilojoule Kelvin per mole. Do you like the units? Yeah? Should be per Kelvin per mole. Care anyway. Can you try this question out, my good folks? Can you try this question out? I'll wait. I'll give you some time. Please try it out. Yeah? Wow, Sai. That was quick. Beautiful. I like it. What do the rest of you guys think? Do you guys agree with what Sai is saying? Do you want to change their answer up? What do you think? I'm fixing the units as we speak while the rest of you try this question out. Should be per Kelvin, right? So I'm just fixing that everywhere. When you make these slides, kabhi thoda sa ghotala ho jata hai, and that I should fix for you because you deserve the best. That's what you're going to get. Give me about 15 more seconds. Count that down while I fix this, and I'll quickly check the chat right after. Yeah, okay, done. Sweet. All right. Who knows, bro? When I gave the exam, it wasn't even called JEE Advanced. So I gave the exam probably before you were born. So yeah, back then. Yes, El Dorado, 17 point something. Okay, 17.2. Rec, awesome, 17.2. सीधा सीखो इन लोगों से, कुछ काम करो, टाइम पास से ज्यादा लाइफ में कुछ नहीं होने वाला. Sai, El Dorado, and Rec have given me 3 answers. Sia has also given me an answer called 17.2. Okay, beautiful, excellent work. And I want to agree with what all of you are saying. Excellent work. But how do you guys arrive at this? This is a straightforward question. Just apply a formula and get there. But since this is one of those sessions where I'm helping you do things from first principles, I will tell you how to derive this. It's very straightforward derivation, right? This is an isothermal expansion, right? And you've got n moles of a gas. It's an ideal gas, so you're in luck. And initial and final volume is given. Temperature also is given. So this is, yeah, straightforward stuff. So if something is reversible, it's really, really slow, which means it has infinite number of steps, just like what I gave you. I gave you a bit of theory there, right? So I can write the expression down as du equal to dq plus dw. And I know that in standard books, they never write dq and dw, right? This is not correct. I'll be very straight with you. This is not correct. You don't write dq and dw. It has no meaning. But bear with me. Just for the purpose of this derivation, I've written it like this. Okay? ऐसे हम लोग लिख रहे हैं. At constant temperature, du is going to be equal to 0. Okay, that's the first step. So once we do that, you put dq equal to minus dw. I know ऐसे नहीं लिखते हैं. We're doing this just for a shortcut to solve it. So this is the first law. I've got this from the first law. I'm going to take another minute to derive this for the benefit of people who are not watching this live, and there are a lot of you not watching it live. So I write dw to be negative pf times dv. You know that at each and every small step, initial pressure is going to be equal to final pressure. Each of those small steps. What small steps? You remember that graph, right? These tiny small steps. Okay, is this pf pi I'm talking about? Okay, so in this distance, p versus v, yeah, dv is that infinitesimal step, and this is pf is the pressure at any of these points. Okay, anyway, you integrate that right from vi to ef, and what you get here is substitute this. Now here's one small thing, right? This p is also a dependent variable. Have you done this in integration and differentiation? P is also dependent on v, so you can't take it out of the integration. So what you do is you write down nRT by v, and then you integrate, you get dv by v, which is ln v, right? Make sure that you take care of the sign. So you can write work as nRT ln v1 by v2 or minus ln v2 by v1, or you can also write ln P1 by P2. You can also do that. So whatever, all permutation combinations, figure it out. Thoda sa practice karo. I've given you the whole derivation. And once you integrate this, yes, you get negative 17.181 as the answer. Excellent work. Excellent work. Yes, Sia. Yes, Sia. Sia, I want to say it's minus nRT ln V2 by V1. Okay, I'll go back there. I'll show you. Yeah, I'll show you. So let's go back to this step right here. When I integrate this, right, I get minus V2 by V1, and then it becomes V1 by V2. Okay? Yes, minus sign needs to be there before that. Yeah, just be careful about that. All right, excellent work, everybody. It's all right, no problem, no problem. Great, you're doing a really good job, Sia. You're doing a really good job. All right, let's look at the next question. The amount of work done in an isothermal expansion is lower than the work done, assertion reason, in JEE. Maybe, why not? Work done in an adiabatic system for the same final volume. It has happened, by the way. A lot of assertion reason questions are creeping into the JEE main system. Okay? Reason is the adiabatic expansion of a gas, temperature and pressure both decrease due to decrease in internal energy system. 2 points. Work done in isothermal expansion is lower than work done in a adiabatic system for the same final volume. Okay. Pf is the same. Okay. That's the statement. Reason is temperature and pressure both decrease due to decrease in internal energy system. What do you think? I'll give you 30 seconds to do this one. You can take longer if you like. This time, as always, is just to tell you कि भाई, this is an ideal time according to me for you to do this. Okay, if you take a little longer, it's okay. But ये वाला तो कर सकते हो. So, like me, in JEE, we are also testing how quickly you're able to read a question and analyze it. Looks like that is happening as well. So, it is a game of speed as well. So, ठीक है? All right. Rec is saying C, Sai is saying A. Okay, Rec is going with C. Array, I was going to write Rec over here. And Sai is going with A. I feel like this timer is not working. Oh, there you go. Timer just worked. Sai is saying, what about the rest of you? Anybody else want to pipe in and give us their opinion? Yeah? Okay. All right. So, in some cases, and in most cases in thermodynamics, it is very easy to do things once you have a graph in front of your eyes. The moment you see the graph, you'll be like, oh, yaar, ye to bahut straightforward hai. This is like, I could do my dreams, right? Ashwini also saying, hey, okay, all right. ठीक है, let's see. Have you read the question carefully? It's saying isothermal expansion is lower than adiabatic system. ठीक है? Sai, do you hear what Sai is saying? Sai has hit the nail on the head. They remember this correctly. If that is correct, then A cannot be the answer. Let's think about that. Let me show you the graph. Right? This is the graph right here. P versus V, isothermal and adiabatic. All right. Hey, Yash, what's up? So, for isothermal system, remember, it said that final volume is the same. Okay. That's what I've done. Same final volume. In an isothermal system, you have that graph. Agar temperature kam ho raha hai, then the second graph will be lower. That is why they say that the adiabatic slope is lower than the isothermal slope, which means that the work done is going to be lower in case of adiabatic, right? Because adiabatic plus this much will be isothermal, right? Hence, W adiabatic is lower than W isothermal. You see that? Yeah? Do you see that? It's okay if you don't know. Abhi, once you hear me out, you will understand this. Any doubts here, guys? Are you okay with this graph? First question. Have you seen this graph in your life before? If you haven't, no problem. Do you listen to what Sai was saying? Adiabatic expansion reduces temperature. Why does adiabatic expansion reduce pressure? Reduce temperature and pressure actually. दोनों चीजें. देखो, delta U is Q plus W. ठीक है? And these are reversible processes because I've been able to plot them on a graph. So ये दोनों reversible ही है. ठीक है? But it's okay. I'm assuming integrate कर दे उसके बाद कर रहे हो. So for adiabatic, Q is equal to 0. So delta U is equal to W. Okay, cool. What does that mean, guys? For work to happen, it happens at the expense of internal energy. Matlab, internal energy, the final one, is going to be lower than the initial one because this is minus P delta V and this P delta V is positive. So delta U is going to be negative, which means that T2 is less than T1. Yes, T2 is less than T1. Do you guys agree with this? Music, आंसर तो दे दो. स्पीड फास्ट क्या करें? आंसर तो तुम दे नहीं रहे हो, टाइम पास कर रहे हो. आंसर दोगे तुम, तब करेंगे स्पीड फास्ट लो. आई विल लिसन टू पीपल हु आर गिविंग एन आंसर. ओके, रैंडम टाइम पास करने वालों को आई एम नॉट गोइंग टू गिव मच भाव. ठीक है? सो do you follow this, that T2 is going to be less than T1 when you're talking about this guy right here? Okay, this is 2, this is 1. Folks who gave an answer, which is Sai, Sia, Sita and Ashwini, do you follow this? Yes? Karthik or Kritik and Rek. Yeah? If T2 is going to be lower than T1, then it means ki bhai, this is correct, but this is incorrect. Yes? So if assertion is incorrect and the reason is correct, then the answer is going to be which one? Assertion is incorrect and our reason is correct, which is option D. Alright? Do you guys understand why this is incorrect and this is correct? जो बोल रहा था ना, speed जल्दी करो, music. Do you understand that? Did you give an answer? Did you understand or not? If you didn't, tell me what it is that you did not follow. And we'll go over it again. Are we all right? Shall we go ahead? I'm in no hurry. I know the focus is for you to understand. So ask me any doubt that you have. Cool? Shall we go ahead? Is that okay? Yeah? All right. Sweet. So, a quick idea about reversible adiabatic processes. Because I gave you that graph. Now, where does that graph come from? Okay. How do I know that's the graph for this? Okay. And this is the most beautiful thing about this. We'll quickly look at this. In a reversible adiabatic process, dE is going to be equal to dW. I already told you that dQ is equal to 0. I know, yeah, dQ, dW nahi likhte, that's not standard. That's okay. Ditch that. For now, ditch that. So, I will write dE as NCV delta T or dt and work as minus P dV, right? This from these both expressions. And I know that Cp minus Cv is equal to R. We'll use that quickly. We'll use that as well. Then I will use a basic idea of differentiation. ठीक है? कि if I differentiate, d of PV, then I get P dV and V dP. Okay? Which is going to be equal to NR dt because number of moles नहीं बदल रहे. थोड़ा सा maths है, जरूरी maths है. If you're giving JEE main, you have to make this effort. Okay? I would not bug the NEET folks with this, but if you're going to give JEE main, JEE advanced, and you're focusing on thermo, you need to do this by yourself. This much math zaruri hai. ठीक है? So, I can write this N dt as this whole expression over here, P dV by CV. And then, woof, look at these fancy things that are happening over here. I've written this whole thing down to be this right here. Okay? Why? Because N dt is going to be equal to this. Do you guys follow this? Any doubt here? Okay, I've got two different things. One is that, okay, I take N dt to be equal to P dV by CV, right? And I then substituted N dt itself from this expression right over here. Any doubts here, guys? Yeah? It's okay, rec hota hai. Horribly right or wrong ka koi tension hi nahi hai. Don't worry about it. Don't worry about it. It's a learning experience and it's a beautiful story that we are crafting together. You'll see very quickly that what I was teaching you there is related to this. That graph is related to this very nicely. I'll go back to that. And once I explain it, you will never forget it in your life. Because that's the thing. एक बार समझ लोगे कभी नहीं भूलोगे. You know this derivation? That's great, Sai. That's great. Okay. PV par gamma is 1. You mean constant. It can't be 1. It's constant. PV par gamma is a constant, not 1. Okay, cool. So what did I do here? I took this CV to the other side and then I substituted N dt from all of this thoda sa mathematical manipulation. ठीक है? Then I've just written this down. I take PdV to the other side and divide this, तो ये हो जाता है 1, etc., etc. And gamma is given to be Cp by Cv, right? Right? Then I get this expression. Then I say, कि boss, अगर ये है, तो I can take log on both sides, and then I get PV bar gamma is equal to constant. Now, where am I coming? ये मैं क्यों किया? Why did I do all of this? And how is this related to that previous thing? And this is the most beautiful part. I'm going to erase some of this. Let's not erase it. Let's keep it as it is. कौन सा color use करें? चलो लाल color use करते हैं. The forbidden color. PV is equal to constant. That's this graph. And this graph is PV bar gamma equal to constant. You see what's different between these two? Yeah. It's like saying, I'm going to take another slide here. Let me use the empty space on this to explain this. Right? It's like saying, hold on. It's like saying कि I've got P versus V, right? Which is the same as say X and Y. Now, the graph of XY equal to constant is going to be equal to this. If I draw a graph of X bar 3 times Y, how's the graph going to look like? It's going to look like this. It's going to become more and more rectangular. ये मैथ्स का आइडिया है, ठीक है? अगर डर रहे हो मैथ से, तो stop being scared of math. You need math for physical chemistry for JEE main and advanced. Okay, which is why this graph is below the other graph. Okay, look at this. Because of this maths, it's below the other graph. Is this okay? This is extremely important. Doesn't matter how much time it takes, we'll sort this out. एक graph में we have covered all of isothermal, all of adiabatic expansion. Okay, we good? This is why this graph is lower. Okay, sweet, good stuff. I like it. Let's now talk about the next question. अब इतना आसान सवाल आएगा, you will be like, भाई what is this? इतना पढ़ा है JEE में यही आता है? यही आता है JEE में. Among the following number of state variables is what? Yeah, this has come in JEE main. I'm not making this up. How many of these are state variables? Let me know. Answer, दोस्तों. Okay, Rek is saying 3. Sweet. Which 3, Rek? Can you help me with that? Which 3? Sai is also saying 3. Ganesh is saying 4. Okay. So Rek goes with 3. Sai also goes with 3. Ganesh says 4. All right. UVNH. UVNH. Okay. Okay. Huh. That's interesting. Okay. Cool. Cool. Except for heat. Yes, Sia. Sia, absolutely right. Sia is also right. Ganesh ji, do you see why it is 3? Your friends here are absolutely right. It's internal energy, volume, and enthalpy that are state functions, and heat is not a state function. Heat is a path function, right? And by the way, to explain why heat is a path function, go back to the starting of my session. The first 10 minutes of the session, I spent on explaining just how heat is a path function. Because heat at constant pressure is equal to delta H. Heat at constant volume is equal to delta U. Alag paths, alag values. It so happens that they give you a different state function, which is these two guys. But heat is not a state function. All right. See, everything ties in beautifully together. Each and every question on this slide, each and every theory thing ties in nicely. Tells you a story. Okay, sweet. Let's look at the next question. A system absorbs 10 kilojoule of heat and does 4 kilojoule of work. The internal energy system, wow, these questions seem really easy, huh? This is what is being asked in JEE main. मैं क्या करूं? Try it out. Gives you confidence, doesn't it? Gives you ridiculous confidence. Coaching में कितना पढ़ाते हैं, and that's all they ask you in JEE main. कर लो. Try it out. Just make sure to try and keep track of the signs. That's all you have to do in this question. Take 30 seconds to do it. Time starts now. करें शुरू. Try it out. All right. Yeah, absolutely. Okay. All right. B and B. Sai and Rek are both saying B. Sweet. Must be B then. I trust you guys. Sai, Sia, and Rek are all going with B. And JEE, अरे वाह, JEE भाई खुद आ गए. I don't think this timer is working. I'm pretty sure 30 seconds are up. But okay, you're all absolutely right. Use Q plus W, simple straight stuff. Agam, yes, 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 yes. Yeah, simple stuff, right? Heat in and work out, right? So this is positive, this is negative. 10 minus 4 is 6. That's it, increased by 6 kilojoule. Wow, wow, wow. Next question. This is going to be taking it up a little bit. Okay? 1 mole of an ideal monatomic gas is subjected to changes as shown in the graph. The magnitude of work done by or on. They don't care. See, JEE doesn't even care by or on the system. Kuch bhi hai bhai, bata do. Tell me the magnitude of work done. That's what they're saying. Okay. Nearest integer, ln2, log 2 is given and ln10 is given. Fine. Ln. Dekho, try karo. This means that somewhere there must be some isothermal process. And mujhe dikh raha hai, I see it. This is isothermal. This guy right here is isothermal. I can see that very clearly. Okay? So the devil is in the detail. God is in the details, and so are graphs. Try it out. 3-1 is isothermal. Absolutely right side. You want to try it out? I'll give you a lot of time for this one. I'll give you 45 whole seconds. Take a minute if you want. Try and solve this. Hey world, what's up? Is it wide? I think world is round. Shouldn't we call it round world? Or whatever. Anyway, try it out. If you want help on how to do this, work with a path function. Go along the paths. You have 3 paths. 1 to 2, 2 to 3, 3 to 1. Add all of them up in that direction. Yeah, the arrows are important. Where the arrow ends, that's the final state. Where the arrow starts, that's the initial state. That is how you do graph questions. Please try it out. Please try it out. Take your time actually. Takes more than 45 seconds, that's all right. Shahrukh ji, अरे वाह, Shahrukh ji तो कल birthday था. The release of, what's that movie? The movie on Netflix. November 2nd, that was his birthday, right? 6.2. Rec is being amazingly quick. Rec, सवाल पूछा गया है in joules. Are you sure that this value is in joules? See, the thing with these questions where you don't have options, be a little bit careful. Padhiye, read the question carefully. Excellent work on doing it quickly. But you also have to just cross-check if what you have done is incorrect. I mean, is correct or not. Shahrukh ji, are you able to try this question out? Yeah? How's everybody else doing on this question? You want me to help you on this? I'll go ahead. Since I've already got one answer, I'm going to go ahead. See, the work done is going to be equal to the 3 different paths right over here. 1 to 2, 2 to 3, 3 to 1. The good thing, which halves your work, not halves, but okay, आपका काम काफी कम कर देता, is that this is 0. Why? Because this delta V equal to 0 in this process, right? देखो, this axis is volume and this line means volume is constant. So work is gone there. Now all I've got to do is -1, which is T external, times delta V. This is Vf minus Vi. Can I be sure? Let me just cross check. Okay, this is 1 to 2. Yes, this is final and this is initial for this. Okay, sweet. This is correct. Ye ho gaya 0. And here I've configured minus RT ln 20 by 40. Okay, so 20 must be the final, 40 must be initial. Yes, in this process, I'm going to use a different color now. This is final, this is initial, right? When you go along this line, I will use these colors ताकि आपको देखने में आसानी हो कि what is happening where. Okay, this looks like this is correct as well. 20 is final and 40 was initial. After that is just making sure you do things correctly. RT is going to be the same as PV. Why? Because T is constant. Yeah, and N is 1 mole. Okay, beautiful, isn't it? Everything just ties in so neatly and nicely. And what you finally have is just a straightforward number. And what you get is 6.2. But Rec and Psi, you're absolutely right. But 6.2 ki units hai bar liter or liter bar, right? What you need to do is give the answer in joule, which means multiply it with 100 and the answer needs to be 620. Okay? This is why you have to be careful. See, you are doing this so quickly, which is beautiful. Amazing. You got the 45-second thing absolutely in your bag. But sawal, dhyan se padna is equally important. Okay? Shall we go on to the next question? Yeah. Man, YouTube is a funny place to be. 620, yeah? All right. Yes. Happens, rec. Is that a virus? What is that? Or is that a flower? I don't know. I got flowers as eyes. Anyway, next question. अगला सवाल किया जाए. For the reaction H2F2 giving H2 plus F2, enthalpy change क्या होगा? ये तो डायरेक्ट लग रहा है मुझे. ट्राई करो. एंथैल्पी चेंज. ओ, इसमें तो हमको जस्ट यूज करना है डेल्टा H इक्वल टू डेल्टा U प्लस डेल्टा NG/RT, है ना? टू यूज दैट एंड दैट्स इट. टाइम ऑलमोस्ट अप हो गया है. I've got 7 minutes and I have 1, 2, 3, 4 more questions to go. I think we may overshoot time by around 10 minutes. चलेगा ना? So instead of 1 hour, maybe कम 1 घंटा 10 मिनट हो सकता है. कर लेंगे. दीपक, पहला लाइव लेसन. Stay on point, man. We're doing a thermo session. Focus. And always keep trying, man. If you're seriously asking, always keep trying. It's okay. Time up, no problem. सवाल सॉल्व करो दीपक. Try it out. नहीं यार, अपॉलॉजी की जरूरत नहीं है. You're not being disrespectful. थोड़ा टाइम पास किया. It's okay. YouTube पे होता है टाइम पास. करते हैं सवाल. I'm here to help you. हेल्प ले लो. आपको लाइफ में इतनी हेल्प मिल रही है फ्री में. अच्छी बात है. Try this out, guys. Let me know if you'd like me to, go ahead and solve it for you. Or if you can solve it, that'll be the best. Try it out. I'll give you 30 odd more seconds more to do this. Try करते हैं. काफी लोग हैं यहाँ पे, but chat पे कोई hi hello बोल नहीं रहा है. It's okay. It's not like I'm a strict guy and I'm gonna like shout at you every time you say. But let me know if this is working. Yeah. And if you want me to give you more hints, I can do that. Like for example, the starting point is this, right? Delta U is that value right there. Okay, temperature is given to you. And this is the equation you need to use is this. Delta H is equal to delta U plus delta NG/RT. Rec, give me the answer is 2.43. Rec. How do you get such a small number, Rec? Dekho, delta, see, a good thing to check is delta U is this value. Huge number, big, huge number. So, how is it that we got 2 point? Acha, I know, Rec, what you did. I know what you did, Rec. Sia, can you tell Rec what he did? Sia, excellent work on getting this quickly. Rec, also excellent work. But I have been where you are at all too often. Karo, try Rec. Rec says 2.43. They will correct their answer very quickly. Khair, I'm going to go ahead and solve this for you. Delta NG is simply going to be equal to 1. JEE loves you guys. इतना simple सवाल दे रहा है आपको. Yeah, यहाँ पे 2, यहाँ पे 1. 2 minus 1 is simply going to be equal to 1. Okay. So all you got to do is add them up. And what Rec was saying and how Rec got 2.43 was he forgot to convert this to kilojoule. Either one of these two had to be converted to kilojoule. To convert this to kilojoule, you have to divide by 1000. To convert this to joule, you have to multiply by 1000. So in this case, I have multiplied by 1000 to convert to joules. Okay. I will convert it back to kilojoule iske baad. ठीक है. So if you do this, then what you get is 59.6 plus 2 point something. Okay, which is how you get 57.1. Kari, 2.5 ही होगा ना? हाँ. And this is a scammy way of doing it. This is a nice scam that I like and I have. Everybody has this, right? 25 by 3. हो गया 2500, which is 2.5 kilojoule, right? Take R. I know R is given as 8.314. चलता है इसमें इतना चलता है because it चलता है इसलिए है क्योंकि you're talking about a order of 1000, right? Look at that. 59.6 is kilojoule. This is joule. So इतना चलता है. And the other chalta cheese is in liter atmosphere, R value is this. All right. Yes, Harish, Agam. Yes, I know what you did, Rec. But good job on doing it quickly. Thoda fine tune karne ki zarurat hai. It's time to be the Virat Kohli at the age of 35 and not 25. Man, that innings was beautiful. I don't usually watch cricket, but it was a beautiful innings to watch. Abhi kya chal raha hai match mein waise? I've been doing sessions for the last 2 hours, so I don't know. But ठीक है, cool. 2 hours हो गए क्या? हाँ भाई, 2 घंटे हो गए. चलो, another one for you. देखो ऐसे सवाल आते हैं JEE मेन में. Match the column. देखो, spontaneous process क्या होता है? process with P equal delta P 0, delta T 0, delta S reaction definition, exothermic process. Just थोड़ा सा effort लगा लो भाई, ऐसे सवाल हो जाएंगे. And luck factor is huge. If you get a question like this, you'll be like, yes, मेरे एक सवाल गया. I don't have to worry about this one for sure. This is one of those questions that are, you know, अगर आपने thermodynamics plus NCERT पढ़ी है, you'll be able to do this question. Nothing else is required. Rec, lovely. Rec says 2. Yes. Okay. All right. What do the rest of you think? Sia also thinks it's 2. Sia and Rec are both on the second one. I'm giving your friends a little bit more time to do it. Some of you are trying it out. Try karo. Easy one, right? This is literally NCERT. You read, but you gotta read the whole of NCERT. You gotta read the whole of thermodynamics. If you're like, oh my god, there are people, right? And I'm not making fun of them at all. वो like, यार मैंने ये चैप्टर किया ही नहीं है. अगर if that's the case, then थोड़ा मुश्किल होगा. But मैं इसीलिए बोल रहा हूँ कि please at least read NCERT. By luck, maybe it's possible, right? It's actually fine. You've done the whole of organic. You've done inorganic. Physical is just not your cup of tea. There are a lot of people write NEET and JEE and they skip chapters. A lot of people I know skip this as well. क्योंकि मुश्किल लगता है. करो skip. But NCERT पढ़ लो. Please read NCERT. Because if a question like this comes, you need to answer it. If you don't read NCERT, if you watch a lot of videos like my video and a lot of other videos online, they may not cover these things, you know, or they may go over them quickly and you may miss it. कि ये जरूरी है, right? But NCERT में you will not miss it. Spontaneous process मतलब obviously यार delta G less than 0. Delta P equal to 0 मतलब isobaric. Delta T equal to 0 मतलब isothermal. Delta H reaction. This is the definition. Exothermic process is this. Khatam yaar. So look for A2. Okay, I don't even need the options on this one. Yeah, and not just me. Anybody can do it. B3, C4, and D का क्या होगा? D हो गया 1. Okay, 2, 3, 4, 1. 2, 3, 4, 1. Excellent work. Simple one. मैं blur हो गया. हाँ मैंने ठीक कर दिया माधव. Thanks. Are you serious, Agam? Oh man. Wow. You're messing with me, right? If you're serious, that's amazing. Man, I'm gonna have to watch the highlights. Indian bowling has been on point, right? Shami, Bumrah. Oh my God, guys. Okay, here's another one. ये वाला देखो सवाल. ये भी JEE में आ चुका है. 5 moles of an ideal gas. This is a troll question. I'm giving you a hint. At 1 bar and 298 Kelvin is expanded into vacuum to double the volume. क्या होता है work done? Try करो. Try करो. क्या होता है work done? Try this one out. Already giving answers. इसमें तो 10 सेकंड लगने चाहिए. हाँ, माधव एंड रेक ने कैच कर लिया है. अरे मैंने टाइमर चलाया नहीं. खैर, माधव एंड रेक हैव कॉट दिस वन. हरीश, गुड ट्राई, बट बी केयरफुल. बी केयरफुल. या देखिए, इफ यू आर एक्सपेंडिंग अगेंस्ट वैक्यूम, that just means कि देखो पहला red flag, first red flag is how do you know is this a irreversible? If you're doing the first principle, reversible है, irreversible है, you don't know. That's the first red flag. You don't know, but it's irreversible. How? If it expands to vacuum, it's very very quick. क्योंकि vacuum में the pressure is equal to 0 दिया हुआ है, ठीक है? Irreversible है, and external pressure is 0. Work done हो गया 0. ठीक है? Good evening, Sumi. Absolutely. Free expansion. Beautiful stuff. So, I'm sure you've read this a lot of times, but I hope you've also given this explanation that I just gave you. It's a half-a-minute explanation, but it's an important explanation. चलो, ये है JEE Advanced का सवाल. We have come to the end of our session. Yeah, last question today, I think. Last सवाल. Yeah. माधव, कोई टेंशन नहीं है. बट अगर बिना पढ़े आप इक्विलिब्रियम कर पा रहे हैं, इलेक्ट्रोकेमिस्ट्री कर पा रहे हैं, तो डोंट वरी. आई फील एंड सॉल्यूशंस यू नीड टू नो. माधव, आई विल आंसर योर क्वेश्चन. माधव 2 मिनट दो, ये सवाल कर लेते हैं, या तुम लोग सवाल सॉल्व करो, मैं माधव का एक्सप्लेन करता हूं. आई विल रीड द क्वेश्चन, माधव, देन आई आंसर योर थिंग, राइट? व्हाइल दीस गाइस डू द क्वेश्चन. One more of an ideal gas is at 900 Kelvin. It undergoes 2 reversible processes. Okay, 1 followed by 2. If work done by the gas in 2 processes is same, okay, so W1 equal to W2. Chalo, value of ln V3 by V2 क्या है? You guys solve. I'll explain to Madhav what he's asking and I'll give him an idea. Maybe this is going to be useful to the rest of you as well. नहीं आप सॉल्व करो माधव. What you need is Dalton's law of partial pressure. You need that. And you need PV equal to nRT. You need to be able to play around with it. And thermo में derivations हैं PV equal to nRT लेके. Right? That's what we just did adiabatic process में. If you are able to follow all of this, it's okay. अगर इसमें मुश्किल हो रही तो पढ़ लेना. It's not that big a deal. The part of gaseous state or states of matter that you need has been being taught to you from 9th standard. 3 लॉ होते हैं, उसको कंबाइन करो, आइडियल गैस लॉ होता है, यही तो है गेस ऑफ मैटर, स्टेट ऑफ मैटर, और क्या है ना. एक्सपेक्टेड डेट, आर्यन एक्सपेक्टेड नहीं है, असली डेट आ चुकी है ना आर्यन. आर यू गाइस सॉल्विंग दिस क्वेश्चन? डू यू नीड मी टू हेल्प यू सॉल्व इट? आई थिंक द ओनली कॉम्प्लिकेटेड थिंग इन दिस क्वेश्चन इज दिस. What on earth is U by R versus S? You have seen a lot of graphs in life, I'm sure. But what is U by R versus S? Help, IIT JEE, थोड़ा हेल्प करता हूं. I realize इसमें एक चीज है. Let me help you. इसलिए मैंने इसमें टाइमर नहीं डाला है, right? Because JEE advanced questions, although they may seem easy, मैं बोल रहा था आसान होते हैं, but यार एक ट्रिक होती है, एक starting point होता है that you need. Once you have that, then you'll be able to do it. I'll give you that starting point. क्या है ये starting point? देखो, in the first process, the y value does not, the x value does not change. So in the first process, delta S is 0, and in the second process, delta U by R is 0. मतलब ये value नहीं बदल रही है, या y axis में change है. Delta S equal to 0, delta S equal to 0. Delta S क्या होता है? Is Q reversible by T. Delta S is Q reversible by T. तो मतलब Q reversible हो गया 0. And remember, this is a reversible process. That's the first thing to recognize. The second thing is delta U by R. ये क्या होता है? ये क्या होता है? Delta U is N CV delta T. है ना? अब CV क्या होता है? CV को भी अब R के टर्म में लिख सकते हो. CV को भी R के टर्म में लिख सकते हो. Right? So, I can say that delta U by R is proportional to temperature. Can I say that or not? Because CV is Cp minus Cv. I'm sorry, what am I doing? Cp minus Cv equal to R, right? So Cv is equal to Cp minus R. Basically some constant that depends on R, right? Cv is 5 by 2R or 3 by 2R or whatever it may be. In this case, it's a monatomic gas. नहीं, दिया नहीं है. Monatomic दिया नहीं है. But it is some X. अच्छा, Cv दिया हुआ है, sorry. Cv is given as 5 by 2R. मतलब it's a diatomic gas. Right? That means that Q is 0 and delta T is 0. Do you see that? Do you agree with this? If you don't, that's okay. You don't have to agree with everything I'm saying. But if you don't agree with me, tell me. I'll help you get there. मैंने थोड़ा डिटेल में बताया आपको. But even then, if you haven't understood, I'll tell you फिर से. First वाला part is okay. Delta S is 0. मतलब कि Q is 0. क्यों? क्योंकि delta S is Q reversible by T. The second वाले path में delta T is 0 because delta U by R is proportional to temperature, right? Delta U is NCV delta T. CV is 5 by 2R, constant है. N is 1. So मतलब delta U is proportional to delta T का delta U by R 0 है. मतलब delta T 0 है. मतलब isothermal है. That's all यार. That's all. अब try करो. Will you try out from here? I will give you 1 more minute to try. अगर आपसे नहीं होता है, I'm here to help you anyway. Aryan, I honestly have no clue यार. I am in the same boat as you. जितना आपको मालूम उतना ही मुझे भी मालूम है. Right? So let's see. Sia, yeah, try. Please try करो इसको. अगम clear है? Try करो. Now that I've told you this, अगर Q 0 है, तो let me tell you the next steps also. अगर Q 0 है, so what you can do is find out work in the first process. Okay. Work in the first process will be given to you by this expression. That work will also be equal to work done in the second process. Also, whatever temperature you get here will be the same temperature here. Whatever temperature you get here will be the same temperature here because delta T is equal to 0. ठीक है? यहाँ पे temperature कुछ फर्क होगा. And this temperature is given to you to be 900 Kelvin. थोड़ा लेंथी सवाल है, but it's okay. JEE एडवांस में टाइम की कमी नहीं होती है. क्या? ये वाला हार्ड है. I agree. ये वाला मुश्किल है. मुश्किल तो है. Madhav, I hope not यार. Madhav, I feel your pain man. This is not fair what has been done. बहुत देर से बताया गया है. I hope it doesn't change again. That's all I can say. क्या करें यार. But either way, जितना भी हो सकता है, we'll help you out in whatever way we can. That's for sure. But I feel you. I feel you. इसके बाद ट्राई करोगे आप लोग? Take another whole minute. Try करो. Work 1, work 2, find out करो. Then you'll be able to get this expression. And once you get the answer, you'll be like, yeah, really, this is the answer. Yeah. So they're not trying to give you very hard maths. They're trying to see if you're able to follow the process. ये वाला थोड़ा हार्ड है, इसलिए मैंने सोचा आपके साथ करूं मैं. बिकॉज समझने के बाद आसान हो जाता है. इनिशियली हार्ड लगता है. But once you understand, you will like, अरे यार यही तो था, यही तो था. क्या था? Work is, हाँ बोलो बोलो जो पूछना है माधव पूछो. इस साल वाला माधव, ऑफ कोर्स इस साल वाला. देखो माधव, अगर लास्ट साल और इस साल में क्या फर्क है? लास्ट साल में पी ब्लॉक एक्स्ट्रा था. पी ब्लॉक कर लेना यार 3 महीने में, क्या फर्क पड़ता है? इट्स ओके, यू कैन डू पी ब्लॉक इन 3 months. इफ अगर वर्स्ट केस सिनेरियो अक्टूबर में बताते हैं, और एब्सोल्यूट वर्स्ट केस सिनेरियो अप्रैल तक टाइम है ना लाइफ में. व्हाट्स द इशू? तो देयर इज नो क्रेजी प्रेशर इन ईदर वे. दैट्स माय ओपिनियन. आई नो राइट आर्यन, कॉन्फिडेंस बढ़ जाता है. इसको ट्राई करते हैं. माधव, जिस लास्ट बार बोलना चाहता हूं कि टाइम बहुत है. कुछ स्टूडेंट्स अपने खुद के ऊपर प्रेशर डालते हैं, यार जनवरी अटेम्प्ट देना ही देना है, नहीं तो फिर अप्रैल अटेम्प्ट हार्ड होगा और स्टूडेंट्स लिखेंगे. तो कुछ मैटर नहीं करता है लाइफ में. लाइफ में कॉन्फिडेंस सबसे ज्यादा मैटर करता है. जो चीज 100% कॉन्फिडेंस हो वही करनी होती है. तो गेट योर कॉन्फिडेंस अप. 100% कॉन्फिडेंस डजंट एग्जिस्ट, आई नो. व्हाटएवर यू आर मोस्ट कॉन्फिडेंट डूइंग, डू दैट. एंड तब यू विल फील गुड अबाउट योरसेल्फ. एंड दैट इज इंपॉर्टेंट. द प्रोसेस में मजा आना चाहिए. And this whole thing of waiting for something good to happen and रगड़ते रहो, yeah, that's not life. Life is pretty short. You have to like what you're doing right here, right now. That's how it works. खैर, बहुत ज्ञान हो गया यार. तुम लोग सवाल बताइए. मुश्किल है क्या? अभी मुश्किल लग रहा है. देखो, okay, the first work done I can get by NCV delta T. N is 1. Okay, CV is given to me by this value here, delta T. So I know that from the graph. अरे अगम, this is not a fake slow clap. I love it, Agam. That's brilliant. Agam says 10. Okay. ठीक है. We'll see why I was clapping. How? ये यहां से आगे क्या करें? देखो, अब ग्राफ थोड़ा यूज करते हैं. ये ग्राफ में देखो, डेल्टा यू बाय आर की वैल्यू दी हुई है ना? चेंज इन आर की वैल्यू दी हुई है. इज सिंपली दिस वैल्यू राइट हियर. या द चेंज इन डेल्टा, द चेंज इन दिस होल यू बाय आर थिंग इज गिवन टू यू, राइट? In the first process, second process से बात कर रहा हूं. अभी we are only talking about process 1. Process 1 में this minus this gives you this same thing right over here. Okay, minus 1800 R. Do you see that? Rec. Yes. Excellent work, Rec. Did you follow the same thing or आपने क्या किया? Or did you do something different? Okay. So this whole thing, delta u by r into r gives you the work done, right? Because q is 0. Beautiful, isn't it? If delta s is 0, q is 0, that means that delta u is going to be equal to w. So delta u by r into r is going to be equal to w. यही तो किया है हमने. आपने भी यही किया होगा. So you get negative 1800 r. Oof. So you equate both of these. And you get delta T to be negative 720 degrees, 720 Kelvin. मतलब सबको क्लीन कर देते हैं. ये 900 डिग्री, ये 180 Kelvin. मतलब Kelvin, right? Not degree. So the temperature reduced by 720 Kelvin, which means the final temperature is 180 Kelvin. Oof. Half done. The second half is now very easy because work 1 is equal to work 2, which is negative 1800 R. Okay. एंड यहां पे आएगा आपका ln v3 by v2. अब आएगा लॉग का मजा. क्यों? क्योंकि दिस इज आइसोथर्मल. ओके, आइसोथर्मल. अरे फिर से मैंने लिखा था. ठीक है, डिच. सो वर्क 2 is going to be equal to minus nRT ln v3 by v2. Why v3 by v2? This is final, this is initial. Okay, final and initial. ठीक है. So this temperature also 180 Kelvin. and you get it up here. भाई हो तो गया, बचा क्या? You get 180 over here. Okay, how do I get 180? Oh, temperature is given to be 180, right? And R is over here. When I divide them both, everything gets cancelled out. All that's left is 10 plus negative over plus ln V3 by V2. Good job, Rek and Agam. And it's okay अगर बाकी लोगों का नहीं solve हो पाया. Sia and everybody else on this chat. A lot of people watching this live. But it's okay. Don't worry about it. The process is important. And what I'm trying to tell you is कि JEE Advanced का सवाल मुश्किल हैं. They are not easy. But they follow a process. There's a method to the madness. आप अगर आराम से you look at it from this point of view, from that point of view, you will be able to solve it. Effort लगता है. और ये एफर्ट लगाने के लिए आपको सब्जेक्टिव सवाल सॉल्व करने पड़ेंगे. फ्रॉम वेयर आई हैव टोल्ड यू दिस मेनी टाइम्स बिफोर. Sumdal. I'll have told a lot of people a lot of times before. I don't know if I've told you a lot of times before, but care. That's the book. Anyway, ping me on iTeach Chem if you have doubts from Zoomdal or anywhere else on physical chemistry or inorganic chemistry. And that was it for today. आज का सेशन यही होता है खत्म. थोड़ा सा बढ़ गया, expand हो गया, just like the gases that we've been talking about. Yeah, that joke was very warranted. I hope you had fun. That's great, Rick. Maza aaya. Okay, Sia, awesome. That's great, Madhav. Beautiful, beautiful. Aryan, JEE में 30 of NTA से क्या फर्क पड़ता है आर्यन? कोई फर्क नहीं पड़ता है. NTA के पास जाए, JEB के पास जाए, IIT के पास जाए. We'll have fun doing this, bro. It's okay. कोई फर्क नहीं पड़ता है. मुश्किल हो, आसान हो. How does it matter? You have to like what you're doing right now. That's what I want to leave you with on this beautiful Sunday evening. ठीक है? जाओ खाना खाओ, have fun. And my plan with you folks for the next week, I'm thinking of starting electrochemistry. A lot of you, I asked on the Telegram channel, Discord पे भी लोगों से पूछा. A lot of you suggested electrochemistry. Some of you said kinetics. It seems like you guys want help in electrochemistry. So that is what I'm going to start with in this following week. उसके अलावा, I will take a couple of classes and I'll continue doing my PYQ session with you on weekends. इसके अलावा, if there's any other help you specifically need, let me know in the comments or ping me on iTeach Chem on Telegram. Lastly, I just did a syllabus wala session at 6 o'clock before this one. It should be on this thing. In that, I've given you all the material you will need for the new syllabus. So koi tension wali baat nahi hai. In fact, we've also done qualitative sort analysis on the NEET channel. It's exactly the same thing for the JEE channel, right? JEE content mein same hai. Look at those videos. You are good. All the notes are there on the Telegram groups. Okay? So join the Telegram group for the latest updates. As always, yaar, like this if you like the video, if you like this teaching, and you share it with your friends as well. That would be awesome. Okay? Chalo. See you guys. And yeah, subscribe if you haven't already. You haven't subscribed, really? I mean, you should. Look at this awesome content, man. Chalo. See you guys. Bye. Good night. Have a great weekend. Bye-bye.